So let's look at these sample problems. Which of the following pairs of aqueous solutions produces a precipitate? Write a balanced chemical equation if you predict a precipitate. Write NR, so no reaction, if you predict that no reaction will take place. So take a moment. So look at these, and all I've given here are the initial reactants. So write out your reactants, write out your products, figure out what your products are going to be, balance it, and then figure out which one will precipitate out. This is what your initial products should look like. K2CO3, it's in an aqueous solution. So your copper 2 sulfate, CuSO4, also aqueous solution. When we mix them together, we know that here's the metal, here's the non-metal. Here's the metal, here's the non-metal. And we know that when we put these together, we're going to have potassium is going to combine with the sulfate, right? And the copper with the carbonate. So we'll have K2, SO4. We don't know if it's aqueous yet, right? Plus, so we're just going to put little brackets there just so we can designate it in a second. We have the copper 2 that is going to combine with the carbonate, so CuCO3. And you all know how these formulas come together, right? You need to know. This is not the time to review that lesson. So, to do that, to identify what state that they're in, which one is actually going to, break apart, okay, dissociate in solution, which is actually going to remain solid, if any, right? So, we need the solubility chart. So, we've got K, right, potassium, guideline 1, soluble. Soluble, and it's guideline 1. Sulfate is over here, also soluble. Because they are both soluble, and this one's guideline number 5, it doesn't really matter what guideline they're in, if they're both soluble. Right? I wrote them down just so you guys can see it. But if you see that they're both soluble, who cares? We know that they're soluble. So what is the state that they're in? Aqueous, right? Aqueous. Now, let's look at the next one. Cu, right? Here it is. So Cu is soluble, and it's in guideline number 5. Carbonate is over here, and it's insoluble. So, which is going to overpower which? Well, carbonate is part of guideline number 2. So the higher of the 2 guidelines is what's going to determine the solubility of that ionic compound. So will that dissolve? No, it will not. So the state is solid. We'll see those. We'll see those. But technically, which one is the liquid? The aqueous, right? Because remember, if we see a precipitate forming, right, we'll still have our entire solution, but we're going to have that kind of chalky material that cannot dissolve in that aqueous solution. That will not dissociate in water. Now let's look at the next example here. Ammonium chloride and zinc sulfate. So we know here's the ammonium, the metal, non-metal. Metal, non-metal. When we put these together, right, the ammonium is going to combine with the sulfate, and we're going to get NH4, 2SO4. Right? We don't know what it'll be, if it will dissolve. We've got then zinc, right, with the chloride. And again, same thing. We don't know which one is actually going to precipitate out. Now, we look for ammonium. So let me just clear off some of this chart here so we can see it. So we clear off, so ammonium, we look for ammonium, and we have ammonium right here, and it's soluble. Let me use a different color. So soluble, and it's guideline number 1. We look for sulfate. Sulfate is down here, also soluble. So because it's soluble, and guideline 5, soluble, aqueous. Zinc chloride. So we've got zinc down here, soluble, and it's guideline number 5. We've got chloride here, which is guideline number 3, which is also soluble. So aqueous. So will we see anything precipitate?
No.
No. So technically, no reaction. So you want to do the work on the side so you don't have to really put out the rest of that equation and then have to cross it out. So you write down that it's no reaction. So you're not really going to see it. So what you're going to see is just the two liquids, right? The two aqueous solutions mixed together, and they're just going to remain mixed together. Right? They're all going to dissociate within the solution. So technically, according to precipitate reactions, we would state that there's no reaction. But technically, yes, there is that combination, but we never really see it because they're not really together. Because they break apart to be surrounded by molecules of whatever the solvent is, which is usually water.